this new piece of information, right? It changes the question ever so slightly. We can use so much of what we've already worked out. I think actually all the hard parts, right? And you just have to work out, well, how far do I need to go before I can now say, all right, now I can put in my new piece of information and I can go on from there, okay? I think the critical line, I wonder if you compare where did you pick up where you left off. I think the critical line is this one. If you've gone further than that, like if you've climbed further back up the question and like maybe you've come to here, you're like, I need to regenerate this series all over again and then I have to cancel all this stuff out. Hopefully you recognize as you cancelled, this line with a very, very minor adjustment should reappear, right? Which tells you, oh, okay, this is where it's important. Now, here's what I've got. Okay? Let me rub off this stuff so that I can pick up from here. Remind me, what is that thing on the left-hand side? Like, it's algebra, but what does that algebra signify? It's a ratio, right? What's it a ratio between? Yeah, good. It's the ratio between two subsequent terms, right? Now, tell me, when you divide, sorry, I'll come back over here. When you divide the next term by the previous one, right? Number one, you've got these coefficients, right? But then you also have, if I don't think about just the coefficients, but if I think about the term, right? The whole term including the x's, right? If I divide the whole term, it will be this coefficient, but there will be something extra hanging on. What's the extra bit? It'll be the x term, right? In fact, it's not just the x term, it'll be exactly 1x. Can you see why there will be 1x, right? Because there's 1x, and then there's 2, and there's 3. So if I divide, say, this one by this one, right, you'll have 1x left over. Or if I divided this one by the previous one, I'll have 1x left over, right, and x, okay? Except you know what x is. It's 3/4, okay? So therefore, here's what you want. You want this. That's all you want. That's the only difference, okay? There's the extra x that we have when we take into account not just the coefficients, but the whole term, including that 1x that's going to be hanging around. Okay. So now I just proceed the way I did before. I can do a bit of simplifying, right? Cancel the 2 out there. This will become 7 minus k on the top. Okay. And then you solve just the way you did before. Now I think what you get is, this is what I ended up with. K is less than 3 4/5. Okay, I think that's what I got. So therefore for k equals 0 and 1 and 2 and 3, that's when the coefficients keep climbing. Okay, they keep climbing. So therefore, which is the important one? It'll be coefficient number 4, right? That'll be the one where they stop increasing after that. This will be the peak. Okay. Now what I actually want is, well, what is the greatest coefficient? So you chuck it in. Here's the general term. So it'll be C4, I should say T4, which will be 7 choose 4, 4 lots of that, and 3/4 to the power of 4, right? Because there's my x to the 4 there. Okay? You can work that out. What do you get? 100 and something? There you go. Okay. Now, are you convinced? I hope the algebra holds together, right? But just so you can see it, do you mind circling for me? We can do the same thing as before, right? So here you can see what I've already built beforehand, right? What does this represent in case you didn't see before? You've got your, I'm just going to move over there. You've got which term you're looking at? This is the resulting binomial coefficient. This is how much the 2 to the k will be. Where did that come from? That came from here, that 2, right? Now, this is what happened when we put together all of these guys, and these are the coefficients. But now I want that specific value of x, 3/4, right? So, here we go. 0.75, that's 3/4. I'm going to raise it to the power of whatever term along I am, right? So that'll be this guy. So if in the first place, well, 3/4 to the power of 0 gives you 1, right? So power of numbers, ta-da, there you go. Now you don't need to work that out. What am I going to get though? If I want the actual term, it'll be the coefficients you worked out before, and now these specific values of x. So it's going to look like this. That coefficient times that particular value of x. Okay, so you get something pretty boring at the top, but now, do you recognize it? Okay, hold on for the sake of it, since we can. Let's do some different ones, shall we? Let's go. How about this guy? No, too much for my eyes. How about that? There you go. So again, you can see there he is. There's the most green one. Okay, or maybe that's confusing you too much. Too much rainbow for me. Sorry. How about this? Let's do that. There you go. So you can see there's the deepest one. There's the peak. That's the greatest coefficient that you already worked out. 177 and 3/16. Okay.